Hi students, before going to watch this video, please do watch the previous video because this video is the extension of the previous video. In the previous video, I have clearly explained the basics involved in the spectroscopy. Please do watch it, then watch this particular video in order to understand the topics very clearly. So in this particular video, I am going to talk about the three segments. The one is whenever the UV visible radiation is passed through the sample, exactly what happens in the sample. And the second one is what is UV visible spectroscopy. And third one is what is the principle involved in UV visible spectroscopy. So these are the three segments about which I am going to discuss today. So let us recapitulate the electromagnetic spectrum which have been discussed in the previous video. So this is the electromagnetic spectrum. This is the electromagnetic spectrum. And in this electromagnetic spectrum, the radiations, electromagnetic radiations are arranged in the increasing order of wavelength. So since they are arranged in the increasing order of the wavelength, and as the wavelength is inversely proportional to energy, so definitely we can say that this is the decreasing order of energy. That is, from left to right, the wavelength increases, and from right to left, the energy increases. From right to left, the energy increases. From right to left, energy increases. So about the nanometers, I already have explained. Right? Now, the energy associated with the radio waves is 10 to the power of minus 5 volt. The energy associated with the microwave radiations is 10 to the power of minus 3 volt, electronic volt. The energy associated with the infrared radiation is 10 to the power of minus 1 electron volt. Whereas the energy associated with the UV visible, that is ultraviolet visible radiations is around 10 electron volt. Now, as we move from radio waves to the UV visible radiations, what is happening to the energy? Energy is increasing. Energy is increasing. And this particular radiations, which are so called as UV ultraviolet radiations, visible radiations, IR radiations, and microwave radiations, will give the information about structure of the molecule. Hence, the spectroscopy related to these radiations which I have talked about is called as molecular spectroscopy. So, which I have clearly explained in the previous video. Right. Now, as we move from microwave to UV, what is happening, students? The energy is increasing. Now, based upon this, we can say that the energy associated with microwave radiations is less, which is 10 to the power of minus 3 electron volt. Now, whenever the microwave, let us say that this is the microwave radiation and this is the sample. Whenever the microwave radiation is passed through the sample, as these are least energetic, then only the rotation of the molecules takes place. The rotation of the molecules in the sample takes place. Only the rotation of molecules takes place. Now, as this microwave radiation is facilitating only the rotation of the molecules, this particular spectroscopy which is related to the microwave radiations is called as rotational spectroscopy. Rotational spectroscopy, students. Rotational spectroscopy. Now, so do you remember that? Whatever the spectroscopy which is related to the microwave radiations, what is happening to the sample? The molecules present in the sample are rotating, so it is facilitating only the rotation of the molecule. So since it is facilitating the rotation of the molecule, whatever the spectroscopy which is related to the microwave radiation is called as a rotational spectroscopy. Rotational spectroscopy. Rotational spectroscopy. Now, as we move further, that is, as we move from microwave to IR, what happens is the energy is increasing from 10 to the power of minus 3 electron volt to 10 to the power of minus 1 electron volt. 10 to the power of minus 1 electron volt. The energy has been increased. Now, whenever this more energetic infrared radiations, which are more energetic when compared to the microwave radiations, are passed through the same sample, then what happens is rotation of the molecules in the sample takes place. Along with that, vibration also takes place. Along with that, vibration is also takes place. Why? Because the energy associated with infrared radiations is more when compared to microwave radiation. So rotation followed by vibration of the molecules takes place in the sample whenever the IR radiations are passed through the sample. Now, this infrared radiations are facilitating the rotation followed by vibration in the molecule. Hence, the spectroscopy related to infrared radiation is also called as a rotational vibrational spectroscopy. Rotational vibrational spectroscopy. Rotational vibrational spectroscopy. Right? Or IR spectroscopy, because IR radiations are the one which are facilitating the rotation followed by vibration. So that's the reason it is also called as IR spectroscopy. Right. So as we move further, what is happening, students? In the case of the UV visible, so we have to talk the UV visible in the combined form. So UV visible spectroscopy, that is whatever the spectroscopy which is related to the UV and visible is one and same. That is, we have to combine the UV radiations with the visible radiations. Now, what happens? So as we are moving from infrared radiations to UV visible radiations, the energy is increasing from 10 to the power of minus 1 to 10 electron volt. Now, as the energy is increasing, what happens, students? Rotational changes take place, because for the UV visible radiations, it should cross the microwave radiation and the IR radiation. So whenever it is crossing the microwave radiation, the rotation of the molecule takes place. Whenever it is crossing the IR radiation, rotation followed by vibration takes place, followed by whatever the electrons present in the molecules of the sample will excite from ground state to excited state. Excites from ground state to excited state. That is what happens in the case of UV visible radiations. Whenever the UV visible radiations, which are more energetic, are passed through the sample, the rotation of the molecule takes place, followed by vibration of the molecule takes place. Immediately, the transition of electrons takes place. So, transition of electrons takes place. Right. So, whenever we are talking about the transition of electrons, definitely we have to discuss the transition of the flexible electrons, students. The transition of flexible electrons. Let us give a pause to it. I will discuss about this transition later. Now, this microwave spectroscopy or rotational spectroscopy. That is, whatever the spectroscopy which is related to the microwave radiation is called as microwave spectroscopy or rotational spectroscopy. This spectroscopy, microwave or rotational spectroscopy, will give the information about bond length and bond angle of the molecules. Bond length and bond angle of the molecules. Now, whatever the IR radiations are there, infrared radiations, the infrared radiation, whatever the spectroscopy which is related to infrared radiations is called as IR. Infrared radiations is called as IR spectroscopy or rotational vibration spectroscopy. And by means of this IR spectroscopy or rotational vibration spectroscopy, we can know the information about the functional group present in the molecule. So this IR spectroscopy or rotational vibration spectroscopy will give the information about functional groups present in the molecule. Functional groups present in the molecule. Functional group present in the molecule. Right. Now, what sort of information can be revealed with the help of UV visible spectroscopy? That is, what sort of information can be revealed by the radiation which are so called as ultraviolet and visible radiations. Before that, do remember, students, here we are saying that UV range is 10 to 400 nanometers. Visible range is 400 to 800 nanometers. When we are saying that UV electromagnetic range is 10 to 400 nanometers and visible electromagnetic radiations range is 400 to 800 nanometers, when both are combined, it should be in the range of 10 to 800 nanometers. 10 to 800 nanometers. But for recording the UV visible spectra, 10 to 800 nanometers wavelength is not used. Only the wavelength in the range of 200 to 800 nanometers is being used. Though the UV visible radiation minimum is 10, maximum is 800 nanometers. But for recording the UV visible spectroscopy, we will depend only upon this particular range of wavelength, that is 200 to 800 nanometers only. 800 nanometers only. Now, we have to discuss why we are going to use the 200 to 800 nanometers, even though the UV visible radiation wavelength ranges from 10 to 800 nanometers. 10 to 800 nanometers. So because of the two reasons, we will not record the UV visible spectroscopy or UV visible spectra from 10 to 800 nanometers, even though the minimum value is 10 nanometers and the maximum value is 800 nanometers. The one reason is, students, there is no exact source of the UV visible radiation in the range of 10 nanometers to 200 nanometers. This is one reason. And the second reason is, in the range of 10 to 200 nanometers, the molecules becomes saturated. So these are the two reasons which prompt us to incident or project the UV visible radiation in the range of 200 to 800 nanometers only. So what happens when the molecules become saturated? I will discuss later, students. Keep these two reasons in the mind. Why 10 to 200 nanometers wavelength is not being used for for recording the UV visible spectra, even though the minimum value is 10 and maximum value is 800 nanometers within the range of UV visible. UV visible. Right. Now, let us come back to our UV visible spectroscopy. Now, already I have said, students, that is, whenever the UV visible radiations are passed to the sample, as these are highly energetic because its energy is around 10 electron volt, rotation of the molecules takes place, rotational changes occurs, vibrational changes occurs, along with that the electronic transitions takes place. So whenever we are talking about electronic transition, students, we have to talk about which electronic transitions precisely. What are those electronic transitions? Because all the electronic transitions is not possible. Electronic transition means what, students? Transition of electron from one energy level to another energy level, or transition of electron from ground state to excited state is nothing but electronic transition. It's nothing but electronic transition. Right. Now, whenever we are talking about electronic transition, we should talk about the transition of the flexible electrons. We should talk the electronic transition in terms of flexible electrons. Now, among the sigma electrons and pi electrons, which are the flexible electrons, students? Pi electrons are flexible because the sigma bond is strong. Already you know, you have been studying since your childhood that the sigma bond is more strong when compared to the pi bond. Since sigma bond is more strong when compared to the pi bond, definitely we can say that whatever the electrons which are associated with the sigma bond are rigid in nature, and whatever the pi electrons which are associated with the pi bond are flexible in nature. So whenever we are talking about electronic transitions, we are talking about the transition of flexible electrons. So what are those flexible electrons, students? Those flexible electrons are the pi electrons, and the pi electrons are a part of the unsaturated molecules. And which class of organic molecules comes under the category of unsaturation? That is alkenes and alkynes. Accordingly, we can say that UV visible spectroscopy gives the information about the number of unsaturated bonds present in the molecule. That is, how many number of the double bonds and triple bonds are there in the molecule can be revealed with the help of the UV visible spectroscopy. So, just remember, students, microwave spectroscopy is giving the information. Microwave spectroscopy is also called as rotational spectroscopy. Why it is called as rotational spectroscopy, I already have discussed. It is giving the information about bond length and bond angle of the molecule. Whereas the IR or rotational vibrational spectroscopy is giving the information about functional groups present in the molecule. Whereas the UV visible spectroscopy will give the information about number of double bonds present in the molecule. That is, it gives the information about unsaturation present in the molecule. Unsaturation present in the molecule, students. That is, for example, let us say that lambda obtained is 217 nanometers. Lambda obtained is 270 nanometers. So, in the spectra, against the wavelength and absorbance, let us say that the band is absorbed at 217 nanometers. If the band is absorbed at 270 nanometers, that clearly indicates that our molecule is 1,3-butadiene. Our molecule is 1,3-butadiene. Right? 1,3-butadiene. 1,3-butadiene. So in the similar fashion, each and every molecule has their own identity, has their own wavelength. This wavelength which is associated with this 1,3-butadiene is like a fingerprint. It is unique. It is unique for each and every molecule. So if in the UV visible spectrum, the wavelength or the band, the lambda max is absorbed at 270 nanometers, that clearly suggests that our molecule is 1,3-butadiene. On the other hand, if the band is absorbed at 255 nanometers, then we can reveal that the sample which has been placed in the UV visible spectrophotometer is benzene. Students. So benzene is also the unsaturated molecule. Right? Now the UV visible spectroscopy is giving the information about the number of double bonds present in the molecule. Not only it is giving the information about the number of double bonds present in the molecule, it is also giving the information about what exactly the molecule is. If the band is absorbed at 270 nanometers, then it gives the information that our molecule, our sample is 1,3-butadiene. If the band is absorbed in the UV visible spectrum at 255 nanometers, means our sample is benzene. So this is the importance of UV visible spectroscopy, students. It gives the information about the number of double bonds present in the molecule. It gives the information about the unsaturation present in the molecule. It will also give the information about the triple bonds as well. Unsaturation means double and triple bonds. I hope you understood this. And do remember that each and every molecule absorb at one particular wavelength only. It is the fingerprint for each and every molecule. So our fingerprint is unique. Just like our fingerprint is unique, the lambda max, that is lambda max means the wavelength the absorbed by the molecules maximum is unique for each and every molecule. I hope you understood this particular concept, students. So with the help of that, I would like to define the UV visible spectroscopy, and I will give the principle involved in the UV visible spectroscopy, and about the remaining topics in the UV visible spectroscopy I will discuss in the next video. Right? Just definition and principle. So this UV visible spectroscopy. So during the UV visible spectroscopy, what is happening, students? The transition of electrons is taking place. So since during the UV visible spectroscopy transition of electrons is taking place, this particular UV visible spectroscopy is also called as electronic spectroscopy. It is also called as electronic spectroscopy. Right? So UV visible spectroscopy or electronic spectroscopy, both are one and same. Now coming to the definition. Right? Coming to the definition. What is UV visible spectroscopy? UV visible spectroscopy is the study of electronic transition in a molecule, or it is a study of electronic transition occurring in the molecule upon irradiation of the molecule with the UV visible radiation. UV visible radiation. So what do you mean by irradiation, students? Irradiation means what? Irradiation means whenever the radiation is passed through the sample, what is happening to the sample? That is nothing but irradiation. right? So that is the definition of UV visible or electronic spectroscopy. Coming again, UV visible spectroscopy is the study of electronic transition taking place or occurring in a molecule upon irradiation of molecule by UV visible electromagnetic radiation or UV visible radiation. So that is nothing but the definition. So coming to the principle, already I have explained, but coming again, the principle involved is very simple, students. So already I have discussed that the UV visible radiations are highly energetic. So since the UV visible radiations are highly energetic, when these highly energetic UV visible radiations are passed through the sample, what is happening, students? Electronic transitions takes place. Electronic transitions take place accompanied by the rotational changes and vibrational changes which records in the spectra. That is nothing but principle. Already I have explained while explaining this. Why it is accompanied by the rotational and vibrational changes? So in order to get the UV visible radiations, first it should pass this radiation which is around 10 to the power of minus 3 electron volt. So which will give the information about the bond length and bond angle. It should pass the IR radiations, infrared radiations. Then it should come to the UV visible radiation. So rotation takes place, followed by rotational vibration takes place, followed by electronic transition. That is, the transition of electron takes place from one energy level to another energy level, or from the ground state to excited state. So in the next video, I am going to discuss about the types of electronic transition, students. And before going to discuss the types of electronic transitions, I will make the video on or exclusively on the possible electronic transitions during the UV visible spectroscopy. Possible electronic transitions. So I hope you understood this particular concept what I have explained. So with this, let us discuss about the possible electronic transitions in the next video, students. So thanks for watching.